morning friends, I welcome you all in this session. As you are aware, in previous session we discussed about measures of central tendency, and the measures which we discussed were arithmetic mean, geometric mean, weighted mean, mode and median. So, in this session we will talk about measures of variation. Now, what is the need of measuring variation? Why you want to measure variation? Because in one of the classes I have said that data generally speak, you need to hear them. So, if you hear them means what? You need to look at various properties of the data. So, when you know more and more properties of the data, you can make a better decision. So, for that only you need to measure variation in the data. So, it will help you, or the measures give you information on spread or variability or dispersion of the data. Let us look at this distribution. So, this is what? This is nothing but mean, mode, median, or it is all these three are measures of central tendency. What is central tendency? A point where the distribution rests, right. So, this is the point where distribution is resting. Now, if you look at these two, there are two distributions. Let us say this is distribution A, this distribution B. So, which has got more dispersion, where there is more variability, in A or in B? So, there is more variability in this distribution. Here data are concentrated, here they are more dispersed, right. So, we will look at couple of methods of variation. So, first is very simple, but the most inaccurate is range. Then we will see variance, standard deviation and coefficient of variation. So, there are 4 measures of variation. So, range is as I said the simplest, the difference between maximum value and minimum value of the data set, right. So, this is your range. So, let us look at this example. So, you got different data points, let us say 1, 2, 3 and so on, right. So, let us say this has got the frequency of 9 number is 3, right. Suppose if I ask you to calculate mode of this particular data set, how would you do it? This is the mode, right, because the number which is occurring most number of times, right, but we are not talking about mode, right. So, we will calculate range. So, the minimum value is from here to here, right. So, minimum is 1, maximum is 14, range is 13, right. Let us look at the problems of range. Why range is not a good measure of variation? It ignores the way in which data are distributed. Let us look at this example. So, there are 6 data points 7, 8, 9, 10, 11, 12. Range is minimum to maximum, right, 12 minus 7, 5 is the range. If you look at this example, so data points are 7, 10, 11 and 12. So, what is the range? 12 highest value, least value 7, range is 5. So, what is the difference? So, here the data are evenly distributed, here there is a concentration of this particular data point. So, but the answer in both these cases is same. So, what we will say? Range ignores the way in which data are distributed, right. Let us look at second problem. It is sensitive to outliers. So, let us look at this data set 1, 1, 1, 2, 2, 2, 2, 3, 3 and 4 and 5, right. Now, if you look at the frequencies, just see how many times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, frequency is 11, here frequency is again approximately 8 to 9, then this is the frequency 4. So, frequency is 1 and 1, range is 5 minus 1. So, if you look at the 90% of data points in this data set are between 1 and 3. So, there is only one point which is 5, and this has affected the range, and the range is 4 here. So, this is sensitive to outliers, right. Another example 1, 2, 3, 4 and 120, right. Now, the range would be 119. So, just one outlier has changed the range. So, that is why because of these two problems we do not use range as a measure of variation. Now, there are different types of range. We have seen in case of measures of central tendency, median. What is median? Is nothing but a kind of range. It is 50% of the data, right, or we will call it median is 0.5 fractile. Fractile is nothing but how you are dividing data, in how many parts you are dividing data. So, each part is known as a fractile. So, let us say you have got 12 data points. So, these are 4 data points, again 4 data points, again 4 data points, right. So, the first 3 data points, so we will call it 1/3 of the fractile or 1/3 fractile. The second third, the second 4 data points, right. So, it is called 2/3 of the fractal. So, 1/3, when I say 1/3, it means 1/3 of the total. This is 2/3 up to this point. So, all these are 2/3. So, this 2/3 fractile, right. So, if we divide data set into, let us say 10 equal parts, each one would be called a decile. If we divide data set into 4 equal parts, it would be called quartile. If we divide data set into 100 equal parts, it would be called percentile, right. So, you can have different types of ranges, right. One more important type of range is interquartile range, which is the difference between Q3. So, let us say there are 4 in a data set, this is your entire data set. So, this first quarter Q1, this Q2, this also median, right, Q3 and this is Q4, right. So, this difference or this distance is known as IQR, interquartile range, which is Q3 minus Q1, right. Let us look at a better method of measuring variation. It is called variance. So, average of square deviation of values from the mean. The good point about variance is that it takes into account each and every data point in calculation of variance, while in case of range what we were doing, we were taking only minimum value and maximum value, the all other values we ignored, while in case of variance we will take into account each and every data point of the data set. Okay. So, sample variance is, this is the symbol for sample variance, S square. So, what would be the symbol for population variance? In one of the classes I talked about these things. I talked about statistics and parameter, right. So, statistics are about samples and parameters are about population, right. So, the sample variance is this, population variance would be this, right, sigma square, right. So, let us look at first sample variance, forget this. Okay. So, this is summation of xi minus x bar whole square divided by n minus 1. So, here x bar is arithmetic mean, n is sample size and xi is the ith value of the data set, right. Now, why this is n minus 1? Why we have divided this by n minus 1? This you have to be very firm. Why this is n minus 1, why not n? So, the answer to this is, what happens, let us say there is a population this, and this is a sample, let us call it S1 sample, and if you calculate its variance, so it would be S1 square, right. So, this is variance of first sample. If you take another sample, this would be S2. So, you can have different samples, right, different such samples. So, at the end of the day, there is something called population variance. So, this population variance should be equal to what? Sum of all these sample variances, S2 variance, and so on, Sn variance. So, these two should be equal, but it is not this, it is not equal. Statisticians and researchers have proved that if you put n over here instead of n minus 1, then these two will not be equal. So, if you put n minus 1 over here in denomination, then only these two would be equal. So, this one of the reasons of having n minus 1 value here, right. So, this sample variance, right. The next measure is standard deviation. So, if you take square root of variance, it becomes standard deviation. Just see this square root of variance is standard deviation. Most commonly used measure shows variation about the mean, is the square root of the variance, that is what I have already talked about, is the same unit as original data. So, this is your sample standard deviation. So, we have seen three measures so far. What are those measures? Range, then variance, then standard deviation, right. So, we will work out couple of examples on standard deviation. So, first of all, how to calculate standard deviation? This is very simple. So, you will have mean first, then difference of every observation with mean, right. Then this difference is to be squared, right. Then you have to add all these differences. So, this is add these square differences divided by n minus 1. So, here I is ranging from 1 to n, right. Okay. Take the square root of sample variance to get the sample standard deviation, right. So, this is what you should do, and this is the same formula, right, you can see here. So, let us calculate standard deviation. So, you have got 8 data points, 10, 12, 18, and the final one is 24, right. So, n is 8, right, 8 data points, mean is 16, right. You just add all these values and divide it by 8, right. So, you will get mean as 16, right. Now, how would you proceed for calculating standard deviation, right. So, this is your first data point 10, right, this is your 10 first data point minus 16 whole square, then next data point is 12 and so on, right. The last one is 24 divided by n minus 1. So, you will get standard deviation as 4.30, right. Since you know standard deviation, if you take square of this, it would become variance, or if you know variance, take under root of it, it would become standard deviation. Let us take one more example on sample variance. In fact, in this case, in this example, we have calculated sample standard deviation first and then sample variance. So, it would be around 17, right, if you take square of this. So, sample variance is approximately 17, right. Let us look at another example. We will calculate sample variance. So, these are different observations. Now, first of all, to calculate variance or standard deviation is what? You need to calculate mean. So, this x bar is 1351. How did you get this? There are how many observations? N is what? N is equal to 12, right? These are 12 observations. Mean is this. So, how did we get this mean? We just summed up all these observations and divided that sum by 12, right? Okay. So, that sum, if you want, you just multiply 12 with this, you will get the sum, right. Now, the third one is x minus x bar. So, x is this, x minus this is this. So, these are first few negative values and then positive values, right. Take the square, summation of that, take square of x value, square of all these observations, right, and the summation is this. Now, put all these values in this formula. So, x minus x bar whole square divided by n minus 1. So, this is x minus x bar whole square, summation is this, divided by 12 minus 1 is 11. So, you will get this value as this. So, sample variance is 144,888 thousands of dollars, because these are some observations in terms of dollars. Since you know variance, standard deviation is this, 380.64 is the standard deviation, right. So, very simple. Only the point you have to remember is that in case of sample variance, in the formula this is n minus 1, right, while in case of population variance it is just simple n. So, this is another method of calculating variance. So, this was the formula we used earlier. Now, we will use this formula, right. This is simple. You just put summation of x square, which is this, n into x bar. X bar is what? 1351, n is 12, right, and take square of this. So, x bar is square. So, n minus 1 11, n minus 1 11. So, this is the sample variance. Are you getting the same answer? It is 144,888. We will check it. 144,888 is the answer, right. So, this sample. So, you can have one more example on standard deviation of group D data, right. So, this is very this is basically a group D data, right. So, for examples we have seen we are having ungrouped data. Now, let us look at this question. It is a question on frequency distribution of return on investment of mutual funds. So, let us say the return on investment is between 5 to 10 rupees or 5 to 10 dollars, and there were such 20 mutual funds, and return was between 25 to 30, and there were such 8 funds, right. So, total 60 mutual funds. We want to find out standard deviation, right. You can solve this question using Excel rather than you solving it through a particular formula, right. So, you just write down serial number here. So, there are total 12 rows. First is this column, lower limit, upper limit, midpoint, number of funds, this frequency is there, multiply f and x, x minus x bar whole square. So, this would be 96.69. So, this x minus x bar. So, 7.5 minus mean, which is 17.33 whole square, right. It would be 96.69. It cannot be negative value, all these values cannot be negative because it is a square term. Similarly, multiply this value by f, frequency. So, you will get this one, and this is the total. So, mean is this, sample variance is this, and standard deviation is this. Just take root of this, right. So, if you look at this slide, what we have done in we had mean in cell number F10, right. F10 is this F10, F and 10. So, F10 is mean. Similarly, you can have standard deviation in cell H12, right, H12. This is another example. Now, here we have to calculate standard deviation of the population. So, find out population standard deviation. Okay. So, this is again a grouped data. So, class interval is 700 to 799, 899, remaining values you can write over here, right, not a problem. So, this would be 1799, right, and so on. Frequencies are given over here. We have to find out standard deviation of the population, right. So, for standard deviation of the population, you need to use this particular formula. So, this is summation of f into x minus mu whole square divided by n. So, these are different class intervals, these are midpoints, frequencies, f into x and summation. So, this is f into x, this becomes 125,000 divided by n. So, n is this small n is frequency, right. So, this is how you will get x bar 1250. This x bar is nothing but mean of the population, that is why here symbol is mu, we have not used x bar. So, this mean of the population just write over here and then calculate x minus mu whole square multiply this column by f. So, this is f into x minus mu whole square, this is 668 4 times 0 divided by 100. So, this is your standard deviation variance of the population. Once you know the variance, just take root of this, it becomes standard deviation, right. So, this is how you can solve a question for finding standard deviation of the population. Let us move on to next slide. Now, we will look at the fourth measure of variation. Why fourth? Because we have seen range, we have seen variance, we have seen standard deviation, and the fourth one is coefficient of variation, right. So, if you have got two distributions having different means and standard deviation, you can compare them. So, coefficient of variance is a measure of relative variability. It is the ratio of standard deviation to the mean. This is the point you should remember. It's a ratio of standard deviation to the mean, right. This is the ratio. Okay. Shows variation relative to mean, how a data is away from mean, can be used to compare the variability of two or more sets of data measured in different units. So, this is the most important application of coefficient of variation. So, as I said, this is population coefficient of variation and this is sample, right. S and x bar are for sample, right. S is what? Standard deviation of the sample, this is mean of the sample. So, just take percentage of this ratio. Okay. Now, again I will ask one more question. If you want to compare standard deviations and there are two standard deviations. So, let us say there are two distributions, this is the distribution A and this is distribution B, right. Now, in which distribution do you think we will have more standard deviation? More standard deviation or more variability or more dispersion? You will have more standard deviation in case of B, right, because it is dispersed more compared to A, right. Now, we will work out couple of examples. So, you have got 3 distributions. You have got data set A. So, the mean of this particular data set is 15.5, okay, and standard deviation is 3.38. I have already taught you how to calculate standard deviation. Data set B, right, and data set C. So, mean 15.5, standard deviation this, mean this. So, if you look at all these 3 data sets, the mean is same, it is 15.5, 15.5 and 15.5. Now, you want to find out coefficient of variation. Let me put it in different way. Let us say there are 3 cricket players. So, mean of all these 3 cricket players is 15.5 and their standard deviation is this for this for second and this for third. So, which player will you choose? Which would be the best player out of 3? While selecting players, you should see a player which has got the highest mean and least standard deviation. So, you just divide this is mu by sigma, right. This is what we have seen, is not it? This is S by x bar, let us call it standard deviation by mean, standard deviation by mean. So, just calculate all these 3 value. So, select the player wherein you get the least value. So, that would be the best player. This is another example. Let us say there are 2 stocks, stock A and stock B. So, average price last year was $50, standard deviation $5. So, coefficient of variation of A is 10%. Average price is last year was this much, standard deviation 5, coefficient of variation 5%, right. So, this is how you can compare them. So, which is a better one, which is a better stock? This one, the least out of these 2, right. So, this is how you can compare different distributions and select the best one. So, let me summarize what we did in today's session. We have seen different measures of variation, namely range, which is not a good measure, you should outrightly reject it, you should use standard deviation, right, because it takes into account each and every data point. So, use standard deviation or variance, right. And the fourth one was coefficient of variation, which we generally use for comparing different distributions. So, with this let me finish today's session. We will have next section and in which we will talk about standardized normal distribution. Thank you very much.